Hello, this is Mike Richmond. I have another mini lesson for biostatistics. This mini lesson is geared particularly towards students in Math 221B Biostatistics at BYU, Idaho. The concepts I talk about here may be applicable to other classes, but there's no guarantee that you're covering the exact same things that we will cover in this class. Today's mini lesson is about Excel and using Excel as a calculator. Many students at the beginning of a semester will ask me, what sort of a calculator do I need to buy for this class? And my answer is usually, you don't need to buy a calculator at all. You just need to understand and learn how to use Excel as a calculator. What I'm going to show you is how to use Excel as a calculator. First, what we're going to do is we're going to do a very simple discrete probability density. So we talk a lot about rolling a die and figuring out what the mean value is for that die roll and what the standard deviation is for that die roll. In the online text, you will see many places where we have tables where we kind of spell that out and show you row by row what's supposed to happen there. Well, I want to show you how to use formulas in Excel to be able to do this in Excel. So let's suppose I've got a six-sided die and I want to figure out what the average roll is on a six-sided die, and then also I want to figure out what the standard deviation is. So I'm going to create a little table here. First thing I'm going to do is pick a cell and just go down each row and specify the value or the number of dots on that cell. Now I've got some extra zeros in here that I really don't need, so let's change the formatting for all these cells. And make them just integers. So I'm going to call the column header of this cell, this will just be X. X is just the value on a single roll of a single die. Okay, the next column over is going to be the probability of that value occurring, or in statistical terms, it'll be P of X. Now, if my die is a fair die, and it's a six-sided die, that means I've got a 1/6 chance for each roll of having that particular number show up. So in other words, the probability of rolling a 1 is 1/6, the probability of rolling a 2 is 1/6, and so forth. So what I'm going to do here is I'm going to actually put the decimal equivalent of 1/6 in here, but I'm not going to just type in the decimal equivalent. What I'm going to do is I'm going to put a very simple formula in here. The way to put a formula in a cell in Excel is you have to be sure and use the equals sign. So I'm going to type in here equals 1 divided by 6 and hit enter. You'll notice that gives me the decimal equivalent of 0.17. This is to 2 decimal places. If I want to increase the decimal places to 3 or more, I can highlight the cell or cells I'm interested in doing that to them, and then I can come up here and I can see this button up here that says increase decimal. If I hover over that, it will say increase decimal. If I click that once or twice or 3 times or however many times I want to do it, it will increase the decimal that many times. So my preferred range is about 3 places past the decimal, depending on what the application is, but you can do whatever you choose to do here. Okay, so the probability of getting a 1 is 0.167. It just turns out that the probability of getting any number on a six-sided die is also 0.167. So I'm going to just copy that down and paste it in the next 5 cells. Okay. Now in order to calculate the mean, what I need to do is I need to take each discrete value, multiply that value by the probability of getting that value, and add those up. So for example, I want to do 1 times 0.167 and put it in this column here, in this row here, and then 2 times 0.167 and put it here, and so forth on down the row. So the column header here is going to be X times P of X. And again, I'm going to use formulas to do this. Let me widen this column up just a little bit. Now I could just punch in equals 1 times 0.167, but there's another simple way to do it within Excel. Again, I'm going to use the equals sign. And instead of saying what number I want to multiply in there, I'm going to call out the cell. And the way I do that is just by clicking on the cell. So if I click on F3, that says, hey, whatever here is in F3, I'm going to do something with that. and I'm going to multiply that. So I'm going to hit the little asterisk, and then I want to multiply that value by whatever is in G3. So my formula is F3 times G3. And if I hit enter, it comes out to be 0.1667. That shouldn't be a shock to anybody. Now here's one of the beautiful things about Excel. If you look down in the bottom right-hand corner of the cell that's highlighted, there's this little kind of dark square. That's called the Autofill square, or something like that. I don't know exactly what it's called. The nice thing about this is if I grab the Autofill square, click, and drag it down, what it does is it automatically fills each of those cells below this original cell with a similar formula. Now, what do I mean by similar? Well, for example, in this cell, you can see the formula says F3 times G3, and that's going to go into H3. Well, Excel is smart enough that if I click down and look at H4, I look at the formula that belongs there, and that's F4 times G4 goes into H4, and F5 times G5 goes into H5, and so forth. So you can see that it's filled in all of the products in column H according to what I wanted it to be without having to go through and do each one individually. So that's one of the nice autofill features that Excel has. Okay, so now what? Well, now I want to sum these up so I can find the average value of a single roll of the six-sided die. So again, I'm going to use another function. Now I can just say H3 plus H4 plus H5. That gets a little bit tedious, so I'm going to use a different function called the summing function. Now there's an entire library of functions here in Excel, and if I want to access that library, I'm going to push on this little button that says f of x, or insert function. When I click on that, you'll notice automatically it sticks an equal sign in the calculation bar. And then it pulls up stuff I've recently used or stuff that they might think is important. I can type in a brief description. So in this case, I just want the sum. So I'm going to type that into my description, and I hit enter. And it says, okay, well, here's some of the functions that use the word sum or have something to do with sums. And it turns out it's that very top one I want, which is sum of number 1, number 2, number 3, number 4, etc. So if I double click on that, I get a new window that pops open that says, okay, you said you want the sum in H11. I'm assuming you want the sum from H3 to H10. It recognizes that those are numbers or blank, and that's going to be the sum. Well, I don't really care about including H9 and H10 in my sum. So if I hit this little icon that says, hey, you get to go select the range, and then I click on H3 and drag it down to H8, and then I hit enter, that will give me the sum of these 6 cells. So hit OK, and my sum is 3.5. You'll notice the formula up here says equals sum of H3 colon H8 in parentheses, and that's 3.5. So that's the sum, also known as the expected value of a single roll of a die, also known as the mean of the roll of a die. Now, if 3.5 seems like a funny answer to you, well, it kind of is, because it's impossible to roll a 3.5. You can roll a 3 or a 4 or a 6 or a 1 or whatever. You can't roll a 3.5, but it turns out that over the long haul, if you roll the die 100 times, let's say, and you added up the number of dots showing at the top each time, and then after 100 rolls you divided that by 100, the value is going to be pretty close to 3.5. If you're bored one day, you could try that out and see what happens. Don't be alarmed at the fact that 3.5 is not a possible roll, because if you think about it, you'll see maybe government data might come out and say, well, the average family size is 2.3 children per family. Well, there's not a family in the world that has 2.3 kids. But if you add a whole bunch of families together and then find out the average number of children per family, you could very easily have a decimal value there. Okay, next thing we want to do is create another column out here. I'm going to widen this a little bit, because this is going to be the component of the variance of the roll of a single die. So the formula for component of a variance, let me put the formula in here, is going to be x minus, I'm going to just type it out as mu, and I'm going to square that. So typically the way to represent squaring a variable is putting the little hat and then putting a 2 after that. So I'm going to have to square that value and then multiply that by p of x. So that's what I want to do in this column. Now let's figure out how to make it into a formula. First thing I want to do is, again, put in an equals sign. So I'm going to say that equals, and then I'm going to use a lot of parentheses here because I want to make sure and keep it all straight. So I'm actually going to put two open parentheses, and then I'll do x minus mu. Okay, x is found over here in F3, and then I'm going to subtract the mean, which is down here in H11, and I'm going to close my parentheses, and then square it, and then close that parentheses, and then I will multiply that by the probability of x occurring, which is in G3. Okay, so there's my formula. I hit enter, and my component of the variance for x equals 1 is 1.041666, etc. That's terminology we really haven't used in the class. I wouldn't get too hung up on it, but just so that you know that when you do the formula, do the calculation, that's what it turns out to be for x equals 1. I want to use the autofill corner on my cell to do that again, but I want to show you something. So I'm going to just go down one square, and I get a number of 0.666, which looks like it's okay, but if you pay close attention, what's really happening here is it's doing F4 minus H12. Well, F4 is 2, that's what we want, but H12 is blank. What's happened is when you've autofilled in a down direction, it takes every cell that's referenced in the formula and moves it down one spot. Well, I don't want to move the mean down one spot because there's nothing there. I want it to be the mean still. So what I need to do is I'm going to delete what's in this cell right here, and I'm going to come back up to this original formula for the component of variance. There's a little trick that Excel uses that will help me to keep something from increasing in value every time I move down a row when I'm doing an autofill. And that trick is to come up to the row number in the formula. So I've got F3 minus H11, but I don't want that 11 to keep increasing. I want it to stay at 11. The way to do that in Excel is to use the $sign. So now I've got, I wanted to pop that open so you could see it a little better here. Okay, now I've got F3 minus H $11 raised to the second power, or squared, times G3. Okay, that's the right formula. Still gives me my same answer there, but now as I do the autofill, I will actually get the values I want. If you look down here, you'll notice there's some symmetry. The component of variance associated with x equals 1 and the component of variance associated with x equals 6 are both the same. But if I double click on a cell, you'll notice they're still doing the x value minus the mean, so that 11 hasn't changed. All up and down these cells, it stayed the same. Okay, good. So now I've got all my components of the variance calculation. I want to sum those. So once again, I'm going to do equals sum. I know that the formula is, so I don't need to go to the formula editor or the formula the function insert button to find out what's going on. So I'm going to just type in equals sum, open parentheses, and then I'm going to highlight the cells I want to be summed. In this case, it's I3 through I8. Close my parentheses and hit enter. And the sum of those values is 2.91666. Okay, so that's the variance. If I want to calculate the standard deviation, if you remember, standard deviation is just the square root of the variance. So in this next cell down, I'm going to ask for the square root. The square root function in Excel is SQRT. If I don't remember that, and I need to figure out what it is, I can go into f of x and I can just type in square root, hit enter, and it'll say, oh, do you mean this? It looks like squirt. It's square root. So anyway, I know that it's square root, so I'm going to type in equals SQRT, open parentheses, click on the cell that I want to take the square root of, close that, hit enter, and it gives me 1.7078, or 1.708 if I round that to 3 places past the decimal. So 3.5 is the mean of a single roll of a 6-sided die, and 1.708 is the standard deviation of that roll. So this is just an easy way to get Excel to do your heavy lifting without having to get a calculator. Now I've shown you some of the basics of using the formula editor in Excel. Now I want to show you what makes it really powerful, especially when you're using the same formula over and over again to make a particular calculation. Let's take a look at how to use this using Excel as a calculator to calculate functions that you'll use over and over and over. Here's a couple of functions just like that. The top function is the z-score associated with a single value of x, or a single observation if you want to call it that. This formula is z equals x minus mu over sigma, where mu is the population mean and sigma is the population standard deviation. There's also another calculation of z that is associated with a sample of size n. That would be z equals x bar. So instead of the single observation like I have in the top formula, the bottom formula looks for the mean of the sample. I still subtract the mu value off, and then instead of dividing by sigma, I divide it by sigma over the square root of n. So this is one of those goofy fraction within a fraction type of calculations that can be a little bit intimidating, but if we use Excel to do it, it'll be quite simple. This is what makes Excel very powerful as a calculator tool. So my first equation, if you recall, is z equals x minus mu over sigma. So I'm going to set up some row labels just so I can keep track of things. I'm going to call this x, this next one mu, this next one sigma. Rather than insert the symbols, I'm just going to spell them out. Just for the sake of clarity, I want to justify those. And then maybe I'll skip a row and I'll put the z in right here. All right. One of the things I want to do here is in row F, I'm going to go ahead and just type out a little reminder of what that row represents. So, for instance, x is my observation. Mu is my population mean. Sigma is my population standard deviation. And then z is simply the z-score. Those are just reminders of what I'm actually doing. Okay. So the way to do this is to the way you want to calculate this is you put in a value for x, mu, and sigma, and then the z-score will be automatically calculated. This is again going to use a formula editor. So let me just throw out some example numbers here. Let's suppose, center that, maybe that'll make that a little bit easier to see. Let's suppose I have a population that has a mean of 420. I don't know what these values are, but the mean is 420, and the standard deviation is 72. And I want to know what the z-score that's associated with the value of 250 would be. Okay, now, just a quick reminder, z-score is an indication of how many standard deviations away from the mean I am. So, for example, if my mean is 420 and my sigma is 72, well, 250 is it's exactly 170 units less than 420. 420 minus 250 is negative 250 minus 420 is going to be negative 170. How many sigmas is that? Well, 72, 144, so it's about 2.5-ish sigmas, and it's going to be negative because my x is smaller than mu. But we don't have to speculate about it. We can just go ahead and put the calculated formula in right here. So this is going to be equals h5, which is my x, minus h6. And then I want to divide that by sigma. Now, you have to be careful when you're doing these in linear fashion, like you have to put them in the formula editor in Excel, because order of operations matters. So if I were to just put divided by h7 right now, it's going to give you the wrong answer. Can you see that if you do that, it's going to do h6 divided by h7 first, and then subtract that number from h5. Well, that's not what we want to do. We want to actually do the subtraction first. So h5 minus h6, I'm going to put those in parentheses, and then hit the divided by bar, and then click on h7, which is my sigma, and I hit enter. And it says my z-score is negative 2.36. All right, why is this helpful? Well, what I can do is I can use this over and over and over again. So if I'm going to just put a little label on here. So this is going to be merge and center those cells up there, and I'm going to call this the z-score calculation for one observation, or whatever you want to say. And I'm going to, just to make it easy to keep a track of this, I'm going to highlight that whole thing, and I'm going to put a big, thick, heavy box around it, a big border, so that it's all kind of self-contained. You could even do this if you want to. You could say, well, I need to fill in these three values here, so I'm going to color those with a little light peach color so I know that those are the values I have to put in. Okay, so I've done that calculation once. Well, what if the next question says, okay, well, you've figured out what the z-score is associated with x equals 250. What is the z-score associated with x equals 510? Well, that's easy. You just come up at x, you type in 510, you hit enter, and you'll notice it changes the z-score to 1.25. Everything's already going to be recalculated every time you enter a new value. What if the sigma is not as big as I thought it was? What if it's only 61? Hit enter, and my z-score changes to 1.48. So this is a very easy way to go ahead and keep track of, to program your formula, if you will, for a z-score for a single observation and have it pop right out. Okay, and then I can come down, I can name this sheet something like helpful Excel formulas for statistics, and I can save it. And that way, next time I want to use it, I don't even have to create it again. It's already there. Let's do another one. Let's come over here and do, this time I'm going to do z-score calculation for a sample of size n. So let me highlight those and merge that. So this is going to be z-score calculation for sample of size n. All right, hit enter there. Let me widen those three cells out just so we can see the whole label. Okay, now this thing has 4 different inputs. So I'm going to copy these 3 inputs from over here, put them right here, but I'm also going to add a 4th input, which is going to be n, which is the sample size. Okay, let me center that up again so it looks good. Widen this a little bit. You can see how it's copied over that box part of that. That's all right. We can get rid of that by clicking on no borders. Get it out of our way for a second. Okay. This is going to have a z-score also. But I don't want to do the whole formula all at once because I got fractions within fractions. It's kind of a mess, so I don't want to do it that way. So let me do some intermediate calculations here. I'm going to call this one the numerator. If you don't remember, the numerator is the top of a fraction, and this one's going to be the denominator. I might need to go back and remind myself what those numerators and denominators are. So let me pop over to my sample size n formula. Here it's z equals x bar minus mu over sigma divided by n. So I can see a change I need to make. So instead of observation, I'm going to actually call this x bar. And instead of a single observation, I will call this sample mean. Okay, now I'm ready. So again, looking at the formula, the numerator is x bar minus mu. That's easy. So I'm going to say, in this cell, I'm going to say equals, don't want to put it there, I don't think. I think I want to put it right here. Equals x bar minus mu. Don't have to worry about parentheses here because it's a pretty straight formula. Okay, you can see what I've done here. I'm actually going to do the words. That would be silly. Can't subtract words from another. So it's going to be equals whatever I put in this cell minus whatever I put in this cell. Hit enter. Right now it says, hey, that's 0 because there's nothing in those cells. Then for the denominator, I want to do sigma divided by the square root of n. So that will be equals sigma, which will be an n7, divided by, and then I'm going to put square root of, open parentheses, whatever's in n8, which will be the sample size. And again, that's going to give me this time it gives me an error because I'm dividing by 0. That's okay, we'll deal with that in a minute. And then last but not least, I'm going to put a placeholder for the z-score. That's called z, and that is going to be equal to numerator divided by denominator. Again, it's going to give me an error because there are no numbers in there, and anytime you divide by 0, that's an error. Okay, let's go ahead and do an example. Let's suppose you're taking a standardized, let's do something else. Let's suppose that you've recently had a baby and you're taking him to the doctor for his 6-month checkup, and the doctor weighs your baby and says, oh, your baby weighs 13.6 pounds. And then he says, we've had a whole bunch of babies in here this month, and the average weight of those babies we've looked at has been 13.3 pounds. Well, overall, nationwide maybe, or worldwide or whatever, maybe the mean, the population mean, maybe the average weight for a 6-month-old baby is going to be 12.9 pounds, and the standard deviation for the population is going to be 0.4 pounds. And we took a sample of maybe 40 babies at the doctor's office, and the average of those 40 babies was 13.6 pounds. Whatever I said, 13.3 pounds, can't remember what I said. Anyway, you can see as I put those values in there, as soon as there are enough values to actually do the calculation, it'll go ahead and calculate it. So this numerator is 13.3 minus 12.9, that's 0.4. Denominator is 0.063246. That's this 0.4 divided by the square root of 40. So the square root of 40 is 6 and change. So 0.4 divided by 6.3-ish is 0.063246. And then my z-score is numerator divided by denominator, that's 6.32455. All right, so now I've got a formula for my calculation of a z-score when I have a sample. There will be several formulas we're going to use this semester that can be done this way, and you can set up a table real easily to go ahead and just plug in variables each time. Again, we'll set these ones all to be pink so that I can remember that those are the enters, those are the values I have to enter to get my z-score. Once I have the z-score, I can go to the probability applet and use that to determine what the likelihood of having a set of 40 babies in this case with a mean weight of 13.3 is, given that the worldwide average is 12.9 and sigma is 0.4. This is a really, really big number for z-score, so basically this is saying that the likelihood that that would happen just based on random variation is essentially 0. That would be the area under the curve to the right of 6.324. So if you don't believe me, you can go and check that out on the probability applet. Anyway, numbers don't really mean anything. I was just making them up, but I just wanted to show you how to use Excel as a calculator, and this is a really useful, helpful way to do this. Now, if you set a spreadsheet up like this, you will be allowed to use it on your quizzes and your exams, so no need to run out and buy a TI-83 for $120 or whatever they cost these days. Okay, thanks for listening.